Hello, welcome back to Algebra. The title of this lesson is called The Quadratic Formula, Part 1. Now, I have two objectives in this lesson. Both of them are very important. One objective is that I want you to be able to use this quadratic formula to find the solution to any quadratic equation, to be able to actually use the quadratic formula that's in every algebra textbook, ever written. And the second thing, I think actually maybe even more important than that, is I want you to understand where the quadratic formula actually comes from. Because most books, almost every book I've ever seen, just kind of throws it in your lap and says, here's the quadratic formula, and then you use it. You learn how to use it. But you don't really know where it comes from, so it just seems like this magical thing that really smart people figured out a long time ago. The truth is, you have the knowledge now to understand yourself where the quadratic formula comes from. So what I'm going to do in the first half of this lesson is derive it and show you where it comes from. I encourage you, even if you don't care where it comes from, to watch me go through it because it will give you skills and practice in doing a nice derivation. And also at the end of it, you'll be really proud of yourself for understanding one of the most famous formulas in all of math. And then at the end of that, we'll use the quadratic formula to solve some problems in this lesson and in the remaining lessons. So we all know that we can take any quadratic equation and we can use the completing the square method to solve any quadratic equation. It turns out that if you apply that completing the square operation to a general quadratic equation with general values, then you can derive this thing that we call the quadratic formula, which then we normally just use the quadratic formula to find all of the solutions, going forward from here on out. And so the quadratic formula is what we're talking about. So quadratic formula. So I think it's really important when I can to show you where some of these things come from. Now the quadratic formula is one of the most famous formulas, everybody learns this guy. And so what it is for any quadratic equation, this means quadratic equation, that looks like this: a times x squared plus b times x plus c is equal to 0. In other words, we've been solving lots of quadratic equations with completing the square. Maybe it was 2x squared plus 3x plus 4. Maybe it was negative 5x squared minus 3 plus 1 equals 0. In other words, a and b and c are just numbers, and they can be any numbers. And if you choose any random numbers for a and b and c, then you have different quadratic equations. And we know how to solve all of them because completing the square operation makes it so that I can factor the left-hand side of any of those things and solve them. We've done tons of examples using completing the square. If you haven't watched my lessons on completing the square, I recommend you go do that because that's what we're going to do basically here. But the quadratic formula says, as you will see it displayed in most of your books, that the solutions to this is as follows. The solution is something like that, like this. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c. And this whole monster numerator is over the denominator of 2 times a. Now, one thing I'm going to tell you right away is that you're going to get used to using the quadratic formula because you use it all the time. A lot of students will say, well, we already learned completing the square. Why do we need this quadratic formula thing? Well, the truth is, completing the square is a really useful thing that we learn to learn how to use algebra, but once you learn the quadratic formula and where it comes from, there really isn't much of a need to ever really use completing the square too much, because we can just plug the values into this equation and get the solutions directly instead of going through the whole process of completing the square. In other words, if I know any a, any b, and any c for any quadratic, I just put them in these locations and then calculate the answer, and I get always two solutions because you have the plus and the minus. And if you remember back when we did the completing the square, all of those solutions had a plus and a minus there as well. And that's because of the way we did the solution technique. When you take the square root of both sides of something, you have to insert the plus and minus. And we get we've done all that before, but you can see that for completing the square, we always got those two answers. So you can already see the similarity here because we have a plus and a minus in here that is ultimately going to come from completing the square. So this is the famous quadratic formula, so I'll go ahead and box it. It's the most important formula that we probably have. If I had to pick one, I would say the quadratic formula is probably the most important formula in algebra. Most students don't know where it comes from. So let's figure this out. Where does it come from? You have the knowledge. Let's take 5 minutes and figure out where one of the most famous formulas in math actually come from. So here we have a general quadratic equation, ax squared plus bx plus c is equal to 0. If I told you, how do you solve this equation using completing the square? What would you do? A lot of students would just freeze up because they have all these letters everywhere. They don't know what to do. But in your mind, just pretend that it was like 2x squared plus 3x plus 4 is equal to 0. Well, the first thing you would do is you would take the constant term, this term here. Because this is the square term, this is the x term, this is the constant term. The first thing you do is take that square term and you would move it to the other side of the equal sign. That's what we always do when we start to complete the square. So what we would get from this step is the following. All we do is subtract c from the left, so it disappears, and we subtract it from the right, so we get a negative c. The next thing we do is we take a look at the coefficient in front of the x squared term. When we did the completing the square, we said we have to have this coefficient equal to 1. If it's not equal to 1, which in this case it's a, it's not equal to 1, we have to divide both sides of the equation by a to get rid of it. So what we'll do is we'll say, well, we have ax squared plus bx equals negative c. I've just written the whole thing down again. We'll divide the left side by a, and we'll divide the right side by a, because we can do anything we want to both sides to be legal. So then what we do is we look at this, and we want to do the cancellation. We're going to break this up into two fractions like this. We're going to break it up into ax squared over a. The plus sign comes from here, and then bx over a. And on the right-hand side, it's going to be negative c over a. So all I've done here is break it up. Now, if this looks unfamiliar to you, if I ask you, how do I add these fractions together, because there are fractions, I want to add them, how would you go backwards? Well, I have a common denominator, so the common denominator of my answer should be a. Then I would just take ax squared plus bx for the numerator of the answer. So if I add these fractions, I get this. Therefore, I can break this up and go backwards and get this. And the reason I'm doing that is because here the a is going to cancel with the a, leaving me only with x squared. Here I still have a b over a and an x there. So I'm going to write this like this. I'm going to write it as b over a times x. It's just the coefficient of x, for lack of a better word, is the fraction b over a. And on the right-hand side is negative c over a. Now, I'm not going to lie to you, this is an ugly looking equation, but it is no different than any of the other equations we've done by completing the square. You notice we've done exactly the same steps. We move the constant term to the right, then we divide through and make this coefficient of x squared just equal to 1. In the course of doing that, we introduced these fractions, which is not nice. I agree with you, it's not fun. But the next step of the process is very straightforward. What we have to do is take the coefficient in front of x for completing the square. We take the coefficient, whatever it is, we divide it by 2, and then we square it, and then we add it to both sides. That's what we've done for every one of these completing the square problems. So what we do is we say, okay, I'm going, let me see, where do I want to do this actually? I think I want to do it on the next board. Let me rewrite this as it sits. I'm going to rewrite it on the next board. It's going to be x squared plus the fraction b over a times x, that's the coefficient of x, is equal to negative c over a. Now for the next step, what I need to do is take 1/2 of this and square it. So what I want to do is say, well, what is that equal to? So b over a, that's a fraction, right? And I'm going to take that and divide by 2, and I need to square it. This is what I'm going to have to actually add to both sides of the equation, right? So what is this equal to? Well, when I divide by 2, I'm really dividing by 2 over 1. You know, because any number is just self over 1. So I can change this fraction division into multiplication. And then the 2 over 1, when I flip it over to multiply, becomes 1/2. This whole thing is still squared, right? I have to take 1/2 of this coefficient and then square it. So by dividing it by 2, I flip it over and multiply by 1/2, and now I can see that this is going to be b over 2a. You can already see the quadratic formula starting to pop out here. The quadratic formula is negative b plus or minus b squared minus 4ac over 2a. There's a 2a here, and you can already see a 2a starting to formulate in the answer. Of course, we're not there yet, but you can see the seeds of it is kind of starting to happen right here. So this thing, b over 2a quantity squared, is what I need to add to both sides of this equation up here. So let me switch colors. And we're going to add that quantity to both sides. So what it's going to be is x squared plus quantity b over a times x, plus this thing, which is 1/2 of that coefficient squared. So b over 2a quantity squared is equal to negative c over a plus b over 2a quantity squared. So I just added that to both sides of the equation, which is what I have to do. Okay. Now the next thing I want to do is I want to work on the right-hand side, because ultimately I'm going to have to add this stuff together and combine it into one term, but it is ugly the way it sits. So I'm going to draw a little arrow here telling you that I'm only now working on this stuff. So let's see what it would come out to be. Negative c over a plus, now this square is going to apply to the b and also to the 2a. So it's going to be b squared, and then it's going to apply to the 2a as a unit, which means it's going to be 4 times a squared. It's going to apply to the 2, making it 2 squared, and to the a, making it a squared, so 4a squared. All right, now we have to add these fractions together. I know it's ugly, but we have to do it. We have to combine them. So what we're going to have is this is going to be negative c over a, and we'll be adding it to b squared over 4a. But I have different denominators here. What can I do to make these denominators the same? Well, I can, first of all, realize that in the course of this, it's actually 4a squared on the bottom. Sorry about that. It's just 4a squared on the bottom of that denominator. So in order to get a common denominator, I need to multiply this one by 4a over 4a, because then I'll have 4a squared in the denominator. So when I do that, I'm going to have negative c times 4a, so negative 4ac. Notice that this by itself is starting to look reminiscent. I have a 4ac in there, so I'm kind of feeling like this is looking a little bit like the quadratic formula. Negative 4ac on the bottom is 4a squared. All right, and then I'm adding it to b squared over 4a squared. So now I have a common denominator. And so what I'm going to have is, if you think carefully, the denominator of this answer is going to be 4a squared. And it's going to be negative 4ac plus b squared, but I can flip the whole thing around and say this is b squared minus 4ac. And that should look really familiar because the b squared minus 4ac is exactly what's under the radical in the quadratic formula anyway. So I'm adding the negative 4ac plus this, but I'm just writing it backwards as b squared minus 4ac. So this whole thing is what the right-hand side of the equal sign is. Now we got to look and see what is the left-hand side. Normally when you complete the square, you get to this point and you try to factor. You should have a perfect square. I think I need a little more room actually. You should have a perfect square here. And so we know that we're going to factor this. The right-hand side is going to be b squared minus 4ac over 4a squared. And I really want to be careful that we don't get into trouble thinking that this stuff runs together. So this is kind of a border here. Now on the left-hand side, we want to factor this. And I know you're looking at that thinking, that's crazy. How do I factor it? Well, let's just look at it one step at a time. We need an x times an x to give us an x squared. The last term of the trinomial there is a square term. So we need two things to multiply together to give us this squared. So the only thing that really works is b over 2a times b over 2a. Think about it. If you multiply these together, you're going to get this. The b squared, the 2a squared. And everything's a positive sign, so we need a positive and a positive. So we think we factored it correctly, but you should always check yourself. X times x gives us x squared. The last terms multiplied together to give us the last terms. The inside terms is going to be b over 2a times x, and the outside terms are also going to be b over 2a times x, and we have to add them together. So we're going to have a b over 2a. We know that the x is going to be here, so I'm going to just add b over 2a plus b over 2a and check it. We have a common denominator, so we'll get 2b over 2a, which is b over a. So the 2's cancel. So b over a x, that's what we got for the middle term. I'm doing this to show you that this factored form that we have is exactly giving you the middle term that you need, right? So then we're getting very close to the punchline. These are identical terms, so just like we always do in completing the square, it's x plus b over 2a. We're going to make it quantity squared because they're multiplied times each other. On the right, we're going to have b squared minus 4ac over 4a squared. And it doesn't look like we made much progress, but actually the only variable, which is what we're trying to solve for, is in here. So to get him by himself, we have to take the square root of both sides, and this is how the famous radical is going to pop up in the quadratic formula here when we take the square root. So when we take the square root of the left, we're going to have x plus b over 2a. Because we take the square root, it's going to cancel with this. On the right, we're going to have plus or minus a giant radical around all this stuff, b squared minus 4ac over 4a squared, like this. We had to insert the plus and minus when we took the square root of both sides. This is where the famous plus minus is coming from in the quadratic formula. And then what do? Let's go ahead and move this now over. So x is going to then be equal negative b over 2a, because we move it over to the other side of the equal sign, plus or minus. And for this radical, I'm going to make it a radical of the top and a radical of the bottom. So it's going to be square root of b squared minus 4ac. Now you can see it starting to happen. On the bottom, it's going to be the square root of 4a squared, right? So what I want to do here is, I think probably the easiest thing to do is just make an equal sign, because we're getting really close to the answer here. So we have negative b over 2a. We have negative b over 2a plus or minus b squared minus 4ac, all with a radical. And then when we take the square root of 4a squared, the square root of 4 is 2. The square root of a squared is a. So on the bottom, all you get is a 2a. Now notice what you have here. You have this fraction plus or minus this fraction, but the denominators are the same. The denominators are the same. So what do you get? Let's see if I can squeeze it in at the bottom here. You get the following. X is equal to, the denominators are the same, so we can just add the numerators. It'd be negative b plus or minus b squared minus 4 times a times c with a radical around all of that over the common denominator of 2 times a. All I do is say, well, I'm adding these together like fractions, so we have the same denominator in the answer, and I add or subtract these numerators. The plus minus must come along for the ride. Negative b plus or minus b squared minus 4ac, square root of all that over 2a. That's the famous quadratic formula. It's one of the most famous formulas in all of algebra, the most useful formulas in all of algebra, because what it says is if I know any quadratic with any a and any b and any c, all I need to do is put the values in here and calculate the answers. And I will always get two answers because I have a plus and minus here. And so now you can see where it comes from, because you know, it's kind of a lot to slog through in the beginning, but now that we've done so much completing the square, you can see that the quadratic formula comes from taking a general quadratic and just completing the square with it. And that is why we learn completing the square, but then oftentimes students forget about it, because once you understand the quadratic formula, you really don't have a need to completing the square very much, because if I have a quadratic, I'm just going to stick it into this thing. It's a lot easier to do. So in order to show you that, let's do a couple of quick examples here with how to use this famous quadratic formula. For instance, 3x squared plus x minus 1 equals 0. Now if I was going to complete the square with this, I would have to move the 1 over, and then I have to divide by 3 to get it all coefficients right, and I have to take 1/2 of this, square it, add it to both sides, and then I have to factor the left-hand side, and then I'd have to take the square root of both sides, and then I have to move it around, and I'd finally get the answer. But now that I understand and have derived the quadratic formula, I know that in this equation, a is equal to 3, b is equal to the 1 here, and c is equal to the negative 1, which is the constant, and that the solutions of this is just negative b plus or minus b squared minus 4 times a times c, and the entire thing is divided by 2a. And so your equation is going to be negative b, which is a 1, so negative 1 here, plus or minus. On the inside, you're still going to have a 1 squared, b squared, minus 4 times a, which is 3, times c, which is negative 1. The square root applies to this whole thing right here. And on the bottom, it's going to be 2 times a, 2 times 3, like this. And so what you're going to get on the inside, you just crank through it one step at a time. You're going to get negative 1 plus or minus. On the inside, what do you have? You have 1 minus 4 times 3 is 12, right? But negative times negative is positive, so it's going to actually be positive 12. Like this. And on the bottom, you're going to have a 6. So what you'll have over here then is negative 1 plus or minus 1 plus 12 is 13 over 6. Like this. Now, usually you can just leave the answer like that, but since it's our first problem, I'll just write it explicitly out. What this means is you have the answer is negative 1 plus square root of 13 divided by 6. That's one answer. And the other answer is negative 1 minus the square root of 13 over 6. This is exactly the same answer, negative 1 plus 13, root 13 over 6, negative 1 minus root 13 over 6. This is exactly the same set of answers you would get if you just completed the square with the original thing. But because we now have the quadratic formula that comes from completing the square, there's no reason to complete the square in this problem. We'll just take the coefficients and stick it in there and get the answers. But now you know where it comes from, and it doesn't seem like so much black magic, because it comes from something you already understand. All right, let's take a look at a couple more real quick. What if it was the polynomial x squared plus 6x plus 4 equals 0? I want to solve that quadratic equation. Well, the first thing you identify a, b, and c. And from this equation, a is going to equal to the coefficient of x, which is 1. B is going to be equal to the 6, and C is going to be equal to the 4. Those are the three coefficients. That's basically all you have to do there. And I always encourage you to write the quadratic formula down every time so you don't make any mistakes. Negative b plus or minus b squared minus 4 times a times c. The radical has to apply to that whole thing over 2a. And then you just stick it in here. Negative b means negative 6. Plus or minus, we have b squared, which means 6 squared, minus 4 times a times c, and then the whole thing, don't forget this radical that has to sit outside that whole thing, over 2 times a, 2 times 1. So you put everything in place, and then in the following steps, you just crank through and get the answer. So what we have is x is equal to negative 6 plus or minus, under this radical, it'll be 36 minus the 16. And that radical has to apply to that whole thing over 2. So it'll be negative 6 plus or minus. What is 36 minus 16? Let me double check my math here. We have 36 minus 16 is 20. It's going to be the square root of 20, and you'll have a 2. So now it's a little bit harder, or I shouldn't say harder, but because you have a square root of 20, you need to simplify that as much as you can. So 10 times 2 is 20, and 5 times 2 is 10, and I have a pair of 2's here. So if I was going to write this final answer down, it'd be negative 6 plus or minus, but the square root of 20 is 2 times the square root of 5. 2 times the square root of 5 over 2. Now you could circle that and say that you're done. You know, you can. However, you see that this is divisible by 2, this is divisible by 2, and this is divisible by 2. So it's better to break it up and cancel everything. So let's write it as negative 6 over 2 plus or minus 2 root 5 over 2. And all I'm doing is breaking it apart as much as I've showed you in the past. So if you were to add these together, you'd have a common denominator and then this plus minus this. So all I've done is broken it apart. And the reason I did that is because the answer then is more easily read as negative 6 over 2 is negative 3 plus or minus. The 2's now cancel, meaning the square root of 5 is left over. So all you have is negative 3 plus or minus the square root of 5. You have two answers, negative 3 plus the square root of 5, negative 3 minus the square root of 5. And that's the final answer. All right, now for our last one, since we've done a little bit of this stuff, for our last one, we'll crank through it just a touch faster. What if we have the polynomial, or the quadratic, y squared minus 4 times y, whoops, not x, y, plus 13 is equal to 0. So a is 1, b is negative 4, and c is 13. It's always a good idea in the beginning here to write that down. So a is 1, b is negative 4, c is 13, like this. And now you have to plug it into the quadratic formula. So you have negative b plus or minus and all that stuff. I do recommend in the beginning you write it down every time you use it. Negative b plus or minus b squared minus 4ac, square root goes around all of that, over 2a. And so you just plug things in. Now the trick here is you have a negative b, but b itself is negative. So in order to avoid any problems, the negative comes from here. You write that down. In parentheses, you put the negative 4 that you're substituting in for b, and that way you never make any mistakes with the signs. Then you have plus or minus, and on the inside, b is squared, but b is negative, so you have to write it as negative 4 squared, minus 4 times a, which is 1, times c, which is 13. And the square root is wrapped around this whole thing. It's very important that you write it down like this so you don't make any problems with the signs. On the bottom is 2 times a, which is 2 times 1. So then x is going to be equal to, the negative of negative 4 is positive 4, plus or minus. On the inside, 4 squared, negative 4 squared is positive 16. Then you have a minus 4 times 13. 4 times 13 is 52. So you're going to have 16 minus 52. You have a square root that lives around that whole thing, and on the bottom, it's going to be over 2. So then, continuing on, you'll have 4 plus or minus. What is 16 minus 52 is negative 36, but we still have a square root wrapped around that, over 2. And then you have 4 plus or minus. Now, we know the square root of 36 is 6. We know the square root of negative 1 is I, so you get 6i. And on the bottom, you're going to have this 2. Same kind of thing. I could probably leave it like this if I want, but I would rather cancel everything. And so what I'm going to do is break this thing apart so I can cancel it and say what I'm going to have is it's going to be 4 over 2. The plus minus comes down from here, and then 6i over 2. And that's going to be equal to 4 divided by 2 is 2. And then I have plus or minus. And then I have the 6 over 2 is going to be 3i. So this is going to be what x is going to be equal to. So here we have the final answer here. 2 plus or minus 3i is equal to x. Again, we have two solutions, but both of them are imaginary or complex, I should say. So in this lesson, I had two objectives. I want you to be able to use the quadratic formula. So we've done that here, and I want you to go on to the next lesson and the next several, because we're going to be doing and using the quadratic formula more and more and more, just to get you really comfortable with it. But equally important with that, I wanted you to know where it comes from. It comes from completing the square, which we've learned and used. Now, once we have this quadratic formula in our tool bag, usually going forward, you'll just solve most problems that are quadratic using this quadratic formula. But that doesn't mean that completing the square was useless, because everything that we learn in algebra builds, and we'll find out that when we solve more kinds of complicated equations, some of the ideas that we used in completing the square will still be useful. So try not to forget it, but the truth is that most quadratics that you'll solve going forward will probably use the quadratic formula if you can't factor it very easily. So follow me on to the next lesson, and we'll continue getting practice with the quadratic formula right now.